So to start with, we discussed the fact that we need to all be start with the same language, the same framework. So to start with, I just want to talk about a few math pointers beyond the mathematics assessment that I want you to take, and that will sort of tell you what kinds of things you're expected to know. A couple of things about math. Well, it's how we represent numbers. Basically, in this class, unless it is otherwise said or it becomes obvious, you need to represent numbers as a decimal number in scientific notation. That is across the board, decimal number in scientific notation. And what I mean by that is numbers like this: 3 square roots of 2, 2 pi, 17 thirds, 4 times 2 to the 6th. Those are not appropriate answers. Those are not numbers. Those are expressions that have not been solved. And so you need to give me a decimal number in scientific notation as an answer, unless it's otherwise obvious. And what I mean by that is physicists actually do tend to use certain abbreviations where it's reasonable and necessary, but you need to learn where those are. So for example, 2 pi is often something that is used rather than the actual number. But for the sake of this class, unless it's completely obvious that you should do so, you should write down the number 6. If pi is 3.14, then 6.28. You can go out to more decimal places if you want. But anyway, 6.28. Before we get into scientific notation, just in terms of decimal numbers, right? 3 square roots of 2 is 4.24. 17 thirds is 5.66666. I just rounded to 5.667, etc. So you need to write out in all cases, unless again you're told otherwise or it's obvious, you need to write out the numbers. Don't leave expressions unsolved. Do not leave expressions unsolved. Okay, that's one thing about numbers. The next thing is scientific notation. In this, let's look at the fourth of these, right, where I have 256. That could be written in scientific notation as 2.56 times 10 squared. Right? Scientific notation is always one number in front of the decimal point times 10 to some factor, right? So all the rest would be correct in scientific notation. But you do not need to use scientific notation unless we are going farther than, and the rule of thumb is 4 or 5 places to the left or right of the decimal. In other words, 256 can be left as 256. 2,560 can be left as 2,564 places to the left of the decimal. But once we get to 25, then it's kind of getting to be a large number. This is going to be 2.5 times 10 to the fourth. That's 5 digits to the left of the decimal. 2560000. Right now, we should really be using scientific notation. Count the number of decimals: 1, 2, 3, 4, 5, 6, 7. So that's 2.5 times 10 to the 7th. So above about 10,000, 10 to the fourth, we should be using scientific notation. Same thing with to the right of the decimal point, right? 0.002, I'm all right with leaving that, although 0.002 is 2 times 10 to the minus 3, but you can leave it as 0.002. 0.0002, now we're getting to be pretty small. You could leave that as with 4 places to the right of the decimal. I'm okay with that, but that is 2 times 10 to the minus 4. But once we get much smaller than that, you have to use scientific notation. Right? 0.000002 is, again, count the number of places that you have to move your decimal to get one digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 2 times 10 to the minus 9. You need to be able to use scientific notation. You need to be able to write your numbers like that. You should never be writing a number that has that many zeros to the left or the right of it. But this also, so scientific notation, rule of thumb is if you're basically more than 4 or 5 sometimes digits to the left or right of the decimal place, you need to write it in scientific notation. But this also brings up the fact of significant digits. How many significant digits should I be using? So let's say you do a calculation on your calculator And that calculation gives you 324176521032. And you say, well, then in scientific notation, I'm not really saving anything because I still got the same number of digits, right? This is going to be 3.24 times 10 to the, okay, count the number of digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th. Oh, but look what I did. I left off the 176521032. And that's because of significant digits. This, by writing the number, this has, I'm going to count the numbers again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This has 12 digits in it. So that's currently written as 12 significant digits. And that's saying that this number is a number that is known significantly or known accurately. But if we're counting something, 12, 10 to the 6th is a million, 10 to the 9th is a billion, 10 to the 12th is a trillion. So this is 3 trillion. So we're talking about cash. If I'm a trillionaire and I have $3.24 trillion in the bank, do I really care about those last $2? Probably not. Actually, I probably don't even know whether those last $2 exist or not, right? That's probably a really bad example, but the idea is that really we only, in most cases, very few cases do we know more than a couple of digits accurately, right? So to significant digits, I rounded this to 3 significant digits. 1, 2, 3 significant digits. I left off the rest. Many of you will have a tendency to just trust your calculator and put all the digits your calculator puts. That's because your calculator doesn't know how many significant digits you're supposed to have. But in physics, we care about the significance of the digits. We care about the fact that if we know we've got 3 trillion of something, we probably don't know that we've got plus or minus 2 of them. We probably also don't know that we've got plus or minus 32 of them. None of these digits are significant. They're not significant. Hence, we typically, now there are rules for significant digits that you're going to learn in lab. We're not going to apply those rules strictly in this class, only in lab. In this class, you should typically, unless you otherwise know you should do something differently, you should keep 3 significant digits in any calculation. That's the rule of thumb, 3 significant digits. If you keep 4, I'm okay with it. But once you keep 6 or 7 or 8, I am going to mark off for you not understanding the fact that those digits are not significant. They're not meaningful. We couldn't really know the number, the answer to that significance, right? If you calculate the speed of a car going down the road, right? Here's my car going down the road. And I were to calculate, and I do some multiplication or division, and my calculator tells me that my speed is, because my calculator can go to 12 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. I'm just putting that, okay, my calculator can go to 12 digits, so it's going to tell me my speed is that much. Is there any possible way in any world that we could measure my speed that accurately? And the answer is no. I could never know my speed to the billionths place. The speed of the car just isn't that constant even. And so we would really, so the calculator might give me that amount, but I should round it to 3 significant digits, 25.1, right? Whatever units. Let's say it's meters per second or miles per hour. I should round it to 3 significant digits. If I keep 4 significant digits, 25.12, that's okay. But once I start going farther out than that, it's really not significant, and it's showing a lack of understanding of the physics behind the problem. A reminder, there are real rules behind how to know what significant digits you should keep, and you're going to learn those in lab. I'm not going to teach those to you here. So the rule of thumb is 3 or 4, 2 or 3 or 4 significant digits depending on the situation, but if you don't know, 3 significant digits, meaning just keep 3 digits of all the digits your calculator gives you. And then if you write it in scientific notation, this would be 2.51 times 10 to the first meters per second. I'd probably just leave it as 25.1 meters per second. This is kind of awkward when we only got 10 to the first. Again, you're really only going to use the scientific notation if we're at 4 or more digits to the left or right of the decimal point. In other words, if I had 2,500 meters per second is the speed of a spacecraft in outer space, then writing 2.5 times 10 to the 3 meters per second would be good. But if I have my cars going at 25 meters per second, I typically won't write that in scientific notation as 2.5 times 10 to the 1. That's just not necessary. Check. Not necessary.